working with math and dates. What I want to do now is continue our conversation about classes. Recently we had a discussion about object-oriented programming, and I want to continue along that path here, utilizing some of the keywords that we've used and taking a little bit further what classes are all about. Now, for the whole time so far, we've been creating our own classes, albeit they've been relatively simple classes for right now. We're going to move into more complex classes here shortly, as well as creating classes to create GUI or graphical user interfaces. But what I want to do right now is just get you a little bit more familiar and comfortable with how Java works, how to use the Java Online documentation, how to use some of the classes that come with the Java framework or the Java API. So I want to start out talking about the math class and specifically what the math class offers me. The math class has several methods and attributes, as you would guess, I'm sure, to help me perform very important mathematical functions. Things like choosing a random number, rounding numbers, choosing a number between 1 and 100, things like that. Then what I want to show you how to do is how to work with Java's mechanisms for utilizing dates and times. Let's say you wanted to have a time and date stamp within your application. Well, I want to show you the classes that you would use that come with Java to help you do that. To begin, let's go ahead and jump out to the online website where we'll find all of our help for anything and everything that has to do with Java, and that's java.sun.com. This website has to become your best friend with Java because it's going to contain anything and everything you need to know about Java. Now, the thing about this website in particular, it does change fairly frequently. I guess, every few years they kind of fix it up, but it seems to be that they change it just the time that you're absolutely need to go out and find something really important. So I want to just kind of click through it with you to get you familiar with it, to get you comfortable with it. So let's go over to the documentation section. And once we get to the documentation section, we'll have to start kind of digging around. We're going to be using the Java 2 Standard Edition platform. Okay, this is where we'll have any kind of J2 SE information. I'm going to scroll down and I'm going to go to the J2 SE View English API docs. I know I've shown this to you before, but let me just kind of take a minute to review. Java has thousands of classes organized into what are called packages. Later on, we're going to spend some time talking a lot about packages. The packages contain all the classes, and there's several, there's a lot of packages you could see here. I think there's somewhere on the order of, 60 to 80 packages. Inside of those packages are the classes. So what I want to do is first start off by going to the java.lang. And java.lang is the critical package. It contains all the core functionality in Java. And one of the classes in the java.lang package is the math class. And that math class is where we're going to find all the necessary tools to perform very complex mathematical calculations. And just so you know, I mean, math calculations aren't just for writing calculator programs. They're for writing programs that generate pie charts and histograms and all sorts of types of charting tools that are frequently used in the business world for reporting. So let's take a look at up here and see what we have. We have public final class math extends object. Okay. Now this is pretty interesting because we've seen some of these words in action. A public class means that the class is accessible. Obviously, we recognize the class key term. The name of the class is math. Extends. If you remember from our discussion on inheritance, we remember that the extends keyword means that there is inheritance involved. So the math class extends the object class, which means it inherits from the object class. What you will find is all classes somehow inherit up back through the object class. Now the final, what does final mean on a class? If you remember in our conversation about method overriding, final methods cannot be overridden by their child classes. Well, final classes cannot be extended. I can't create my own class and inherit from the math class. All right, so let me go ahead and start up Notepad here. And we'll go into Programs, Notepad. And I'm going to go ahead and create a class. So public class math demo 1. And let's kind of set up the template. Public static void main string args. All right, save this off. I'll put it in my C Java directory and math dates. And I'll call this, what did I call this? Math demo 1. All right, so math demo 1.java. And let me compile it just to make sure it compiles. Cool. All right, now it compiled. We know that. Now here's what I'm going to do. I'm going to say extends java.lang. That's the package dot math. Okay, extends that class. And I'm going to compile it again, and let's see the error that we get. Check this out. Cannot inherit from final java.lang.math. I cannot inherit from a final class. So when you see in the Java documentation public final class, it means that you cannot write a class that extends it. All right, so that's what that means. Let's start digging into the class and finding out what's available to us. We've got a ton of information here. Now, the first part of the documentation, you can read up on it, but let's jump down into the fields. The fields are the properties. Notice that they're static. As a matter of fact, you'll see most everything in the math class is static. And if you recall, the static means I do not need to instantiate an instance of the math class in order to utilize that feature or that, that attribute, that field or method. So I could simply do a system.out.println math.py. And Java will print pi for me. So let me compile that. All right, and now let me go ahead and run it. And you can see that we have pi printed out to the screen because all I did was say here math.py. Now the math class has several valuable and really handy methods to help you work with numbers. It's the math class, obviously. If you needed to find the absolute value of a double value, you could use the abs method. You could pass in a float, int, long. Okay, there's a abs method for pretty much most of the numerics. You can find things like the arc cosine, the aid tangent. Again, now, some of these more advanced mathematical functions like arc, cosine, and tangent, you might not be familiar with if you haven't taken any trigonometry. But let me tell you something. They are extremely utilized and useful in calculating, as I said earlier, pie charts and histograms and things like that. All those kind of charting mathematical functions are based on trigonometric functions. Now here's a cool one. Math.random. It returns a double. Okay, it's a static method of the math class. It returns a double between 0 and 1. Between 0 and 1. So that means a random number is any number between 0 and 1, and it's a double from Java. So system.out.println math.random. Okay, so go ahead and print that out. Let's compile that. Oh, let me go ahead and make that instead of our to out. System.our. I'm sure that nice sentiment, but not going to compile, huh? All right, so let me recompile it. And now let's run it. And here you can see I've got pi. This is the first number. That's not from the random number. That's from pi. And then but look at the bottom number. 3.2165 whatever. Let me go ahead and get rid of that, comment that out. Let's recompile it and run it again. And now I'll do Control 2 to run that. And here you can see now I have 0.8. So what we can do, let's say we wanted to grab a number between 0 and 10, right? So you can see that it's a double. So let me go in here ahead here and let me multiply that number by 10. And you can see now that I've multiplied it by 10, I'm starting to get whole numbers. Now what I'd like to show you is a little app that kind of generates some random numbers. So I'm going to use a for loop to print 0 to I less than 10. And I take math.random, which gives me a number, a double, between 0 and 1, multiply it by 10 to get a whole number, and then I cast the whole thing from a double to an integer, which basically is going to hack off any of the decimals. So let me go ahead and run that. And here you can see I get a series of random whole numbers. Let me quit this and let's run it again. Now you can see I'm getting a different set of numbers. How about one last time? And you can see I'm getting a different set of numbers. Now, what's neat about the Java random method is that it doesn't require you to seed it like Visual Basic 6.0. It had a random method, but it required you to seed it, so it was truly random every time. Otherwise, it would take a pattern. Something else that you'll be asked to do a lot working in programming is work with time and dates. You'll be asked to maybe time and date stamp something, or you yourself will simply want to display the time and date to a user. And most of the time and date functionality, the classes for that, are found in the java.util package. For example, we have the date class, we have a calendar class, a Gregorian calendar class, and a time zone class. And these are just some of the classes that Java affords us when working with time and dates. So let's go ahead and start experimenting with some of those classes next. To begin, let's jump into the API. This API is mandatory. I mean, it's absolutely critical that I get you familiar and comfortable with this. Now, last time we left off, we were in the java.lang package. And as I said earlier, most of the time and date information is found in the java.util package. So let's jump down to java.util right here. And here we'll see that we'll find all of the classes that I mentioned earlier that help us deal with working with time and dates. So as the java.util package is loading, you'll see here that we have the interfaces that come up first. And we'll talk more about interfaces later. But let me scroll down, and here you can see we have the calendar class, the date class. We've got other classes in there like the Gregorian calendar class, as you can see, all of which will be used to help us work with time and dates. Now, the date class, this is going to give us an object that represents any given date and time. So let me go ahead and click on the date class so we can see what we get with that. And here we can see that we have java.util.date. And this picture here lets me know that the date class inherits from the object class. As I said, all classes somehow, shape, or form inherit back up to the object class. Now look at this. Public class date extends object. This means, as you're starting to see, we have a public class called date that inherits from the object class. Now, what does implements mean? Well, without giving you too much of the story away, implements means that it uses interfaces. And we'll talk a little bit more about interfaces as we go on. And we can see that the class date represents a specific instance in time with millisecond precision. So it's pretty good. Let's jump down here. You could see, you could read all about, the formulas and the universal time and all this kind of stuff. Here we could see some further instruction about it, but what I want to do is kind of jump down to the constructor. If we wanted to, we could simply just construct an instance of the class by saying new date. Okay, now here we could have specified a year and a month and a date, like the 14th or the 13th, etc. These are deprecated. Deprecated means that they are flagged or earmarked to become obsolete. You could still use them, but when you compile, you'll get a warning about the fact that you're using a deprecated constructor. Here we have a date constructor that takes a long, or a date constructor that takes a string, but it's deprecated. Look at all the constructors that are available. Now here are some methods that we have. We have methods like after, which tests to see if a date is after a specific date, or before to see if we're before a date. We could clone, we can compare, two dates for ordering. We can compare this particular instance of a date to another object if we needed to. We have compare two dates for equality. We have get date, which has been deprecated and has been replaced by the calendar dot get date. And this will give us like a day of the week or the month if we want. The calendar class, as you'll see, has been really used by Java as the replacement in a lot of ways for the date. That's why you see everything is kind of deprecated and then it's replaced by the date. But what I want to do is kind of jump in and do a quick example of utilizing the date method. Now before we do that, I want to jump right up into the java.utils neighbor and take a look at a special class in the java.text package that will help us format and utilize dates to a little bit better degree because it's going to help us kind of write out the dates a little bit better. Now, a really good class to become familiar with is found in the java.text package, and it's called the date format class. And you can see here that java.text, that's the package, .date format, that's the class, extends the text format class, and it itself extends java.lang.object. And let me kind of scroll down here a little bit, and you can see that it's a public abstract class. Abstract here means you cannot directly instantiate it. Instead, this class has several static methods and attributes for you, fields, that you can go ahead and use, just kind of like the math class. Here you can see that it extends the format. So what kind of formatting am I able to do? Well, if you read, you'll come across that you have choices here. You can use what's like the long, the short, the medium, and whatnot. And here it gives you some examples, like short is completely numeric. So our date is 12/13/52 or 3:30 p.m. Medium kind of gives you a little bit more. Long gives you more information. Then finally you have full. So let's go ahead and experiment with this class in the next example. All right, let me bring up TextPad here. Let's create a class. Public class. Oh, before I do that, let me kind of do something here. Remember I've been talking a lot about packages? Well, in order to give myself access to the classes and the packages, I have to import them into my class itself. And when we go over packages, I'm going to give you a little bit more information about that. But right now, just see that I'm making a reference to those two packages. Now I'm going to create a class, public class, let's call it my df for date format example 1. Okay? And then I'll set up our main method, public static void main string args. All right, and let's save this as mydf1. Type mydf1.java. And here we go. Okay, so I'm going to create a date today. Okay, and that's going to equal a new date. Okay, using the empty constructor of the date class. That's the constructor. Then what I'm going to do is I'm going to say date format. Okay, this is format my df for my date format. Now I can't say equals a new date format. This won't work because the date format class is abstract, which means I cannot directly instantiate an instance of the class. Instead, there's a static method of the date format class called getDateTimeInstance, and that will return to me a date formatted however I want. And how do I want to do it? Well, I want to specify a date format of short, okay, another date format of short, and I'll show you what's going to happen here. And then I'm going to specify a locale. A locale lets me put in a country code that says, hey, what characters and specifications do I want to use to go ahead and format and help to format my date, because different places around the world allow you to format dates differently. So I'm going to create a string, and I'm going to say mydf, and then I call the format method of the date format object that I'm going to create here, and I specify my date to it. So here, I've configured my date format object, or you could even think of it as your date formatter, specifying date format dot short in the locale says this is how I want to basically format the date and the time, and then according to what country code. So format the date and the time according to what country code. Then I pass in the date object that I want to format, and then I've assigned that value to a string. So now all I simply do is I do a system.out.println, and I put in my string of date. All right, let me go ahead and compile that. Okay, cool. And now let me go ahead and run it. Control 2. Okay, and here we are. So let's see what we've got going on here. Seems like a lot of work to generate a time and date, but it's very powerful. So I created a new instance of the date class, which gives me an instance of the current time and the date right to the second. Then what I did here is I wanted to format it. So just because I did time, just because I grabbed a date object doesn't mean I can't see it yet. I have to format it. And what I can do using the getDateTime instance is format it however I want. Here I decided to go ahead and format it using shorts. So I wanted to format the month using the short, so that's why we just see 10/11/04, and the date and I wanted to format the calendar date, month, day, year as a short, and then the format of the time, just 11:06 p.m., and then the locale. This is US, kind of looking. So then what I do is I pass that into the format method. So take that date, I've configured it how to format, so call format on that date and print it out. That's what that looks like. I'm going to do one more example, a little bit more complex, that kind of gives you an idea of what it might look like if you were using other countries. Let me show you a more complex example that I wrote. Here I created a class called DateTime1. And the first thing I do here is create a new instance of the date class. Then I create an array of locale objects. And I use locale.us for United States, United Kingdom, and Germany. Then here I create an array of integers called formats, and I specify date format.short, medium, long, and full. This should be full here. Okay. Then what I do is I create a date format variable, and I create an array called strStyleText, specifying short, medium, and full. And I create a for loop just to simply count up and utilizing the locales array for the length. And in it, I'm basically printing the locale, whatever number I am, and display country. So this will say something like US, UK, Germany. Then what I'm going to do is I've nested another for loop in there, and here I'm creating instances of date formatters, specifying the format in the locale, and then what I'm printing out is the name of the format, okay, pulling it from that variable here, and then I'm actually printing out what it looks like. So let me go ahead and compile it and run it. So Control 1 and Control 2. And here we have it. For the United States locale, a format of short prints a date like this, a medium prints it longer, a long prints out October, okay, and then the full gives you the day, month, the date, and the year, okay. Here's what it looks like in the United Kingdom. Short. Notice how the format looks a little bit different based on the locale. They put the date first, then the month, where in the United States we put the month first and then the date. Here you can see in Germany they use periods to separate things as opposed to dashes. And look at here, Montag, October. Notice how they're spelled? That's because I've specified the German locale. In working with math and dates, I wanted to give you some good practice just to kind of get familiar with the API, how to use many of the thousands and thousands of classes that come with the Java API. Specifically, we focused in on the math class, saw that the math class and the date class gives us several, and the time and date classes rather, give us several static methods and attributes in order to use them so we can pull information, calculate math functions or get time and dates. I hope you found this informative, and I'd like to thank you for viewing.